Hello, good evening, everyone. Am I audible to you? Please, can someone write in the chat? So that we can proceed with the lecture. Okay, thank you, Samita. So, good evening. I'm Prableen Kukreja. I'm a PhD scholar from IIT Tirupati. Now we are going to start with the week 6 of the computer network lectures. Share my screen. Just a minute. Just an overview of what we have done in the last class. We were discussing about the transport layer stop and wait sliding window protocol. Then we went through this go back N and SI protocol, various questions. And then what is bandwidth delay product? That's what we have covered. And about the congestion rate, congestion control, maximum fairness, sending rate, and all those things. Any doubts till now? Please make the session interactive one. It shouldn't be like I am speaking and you all are listening only. It should be two-way session in which you can also ask any doubt if you are having. Give the answers. I think today very less participants are there. Don't know why. Okay. Any doubts till last lecture? And go back and SR protocol and anything else? I think screen. Yes. Yes, class. My screen is visible. Everything is fine. Sending rate. Anyone else? I'll come to that AIMD thing, the rate, congestion, and all. Don't worry about that. We'll do this. We'll do the numericals and all again for this congestion control. Anything else? Can I ask what is maximum fairness for the congestion control? What is maximum fairness? And then AIMD and then can anyone answer these all questions? Yes, come on, just give a try. What is maximum fairness? First question. We have covered in last class only. Just to have a connect with the last class. That's why. Yes, come on. Come on, class. Give a try. Don't be like a one-way session. It's okay if you're wrong also. It's looking like only I am speaking. Anyone is listening?
Yes, ma'am.
Okay. So can you tell me about maximum fairness, then AIMD, and then MIMD and AIID? Why not this and why AIMD? And first of all, what is maximum fairness?
So maximum fairness is when we cannot increase the allocation of bandwidth allocation to one particular route without decreasing it for any other.
Mm-hmm. Okay, absolutely correct. If we have to increase the bandwidth capacity of one flow route, then we have to decrease the other one. That is basically the maximum fairness. That is how we are basically balancing it, as we saw the in the last class also. That if we have to increase, suppose like this 1/3 one, like if we have to increase this, sorry, 2/3 part, then obviously I have to decrease this 1/3 part, then only this 2/3 will be increased. That is basically maximum fairness. For like to increase the capacity bandwidth of one flow, we have to decrease for the other one. Now, what do you mean by AIMD?
Additive increase, multiplicative decrease.
Okay, and what is MIMD and AIID? AIIAD?
So MIMD is for multiplicative in both
Mm-hmm.
increase and decrease, and AID is additive in both case.
So, what do you mean by additive increase, multiplicative decrease? Any idea? And what is a like this? These are the full forms you are telling. What actually? What does it mean?
It is used for network flow controlling. So when congestion happens
Hmm.
and packet loss happens, so AIMD is used to uh, basically re-attain the rate at which we can like again send the data. So
Hmm. Okay. Okay. I was thinking to have the numerical afterwards. Okay, let's have it now only so that you'll have the more clarity. I was thinking to skip the numerical part and come afterwards when I'll teach you more about the congestion thing of a fast recovery and all. But okay, I'll like revise it afterwards. But I think at this moment, maybe you don't, you're like many of you are not aware of it, how to do it. So let's, and many of you are, I think, like, I don't know why only one or two are responding in the class. So let's have a numerical thing so that you can also get more clarity about the AIMD thing and how we are going to solve it. Consider, I am not going to tell you. I'll solve the numerical, and then we'll come to these parts, and then you'll understand what is AIMD and what is MIMD, what is AIID, why we are not using multiplicative increase, multiplicative decrease. I'll try, I think so. If you know the numerical, then it's fine. Otherwise, I'll solve the one numerical as usual, and the second one I'll expect from you guys. Consider an instance of AIMD algorithm where window size at the start of slow start phase at slow start phase is 2 MSS and threshold at start of first transmission is 8 MSS. Assume that timeout occurs during fifth transmission. Find congestion window size at the end of 10th transmission. Any idea about AIMD? First of all, I want to ask you that whether should I solve while explaining AIMD, or once you, as I hope so, you have seen the lectures as well, or you have to, you once you want to try, give a try of AIMD and solve it yourself, and or the other option is I should solve and give you the other question. Yes, come on. So how we'll start? We'll start with slow start phase. One is slow start phase. We are starting with 2 MSs. Then we are increasing it by multiplying it with the multiples of 2. It is going to increase. And when we are reaching 8 MSs, which means that the threshold of the start of the first transmission is 8 MSs. Now we have entered in congestion avoidance state. Tell you, like we'll start with 2 MSs and we'll go with multiples of 2, and once we'll reach 8 MSs, which is the threshold, we'll enter the congestion avoidance phase. And once we have entered the congestion avoidance phase, we'll increase it by 1, and then assume that timeout occurs at the 5th transmission. And once timeout has occurred, which means maybe due to packet loss, or I'll say timeout has occurred due to packet loss or some other reason, then we'll set the new threshold. The new threshold will be like whatever the old threshold is divided by 2. Anything you are getting? Yes, class?
So one question, so when we do divide by 2, what do we take? Integer value?
Yes, 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 yes.
So 11 by 2, it would mean 5 or
5.
6?
Floor value. 5. Is it 11? Are you sure?
Uh, I think so, because I at second time second 2 or whatever second unit, it is reaching 8, and after that it goes from slow start to AIMD, like linear
Yeah,
ring.
9, then 9 to 10. And at 5th transmission, timeout occurs. Then 10 divided by 2.
So
It's 10 divided by 2.
okay.
We don't have to increase at 5th transmission. 5th transmission is itself that timeout has occurred.
Oh yes, that's this one.
I hope so others are also solving. If you don't know also, don't worry. I'll start it after 2 minutes, so that if the students who know, like they can have some time to solve it. And then again we'll start with the slow start after the 5th transmission, and then after after reaching the 10th transmission, we have to find out what is the congestion window size at the 10th transmission. That is our main motive. What about others? All are solving, or only 1 or 2% are solving? Yes, it's fine if you don't know also, because I think numericals are not covered in class. It's totally fine. Anyone with the answer? What is the window size, congestion window size at the 10th transmission?
Ma'am, I think answer will be 6.
No. Who is saying, by the way?
Ma'am, me, Saf.
Okay. No, the answer is not 6. What about others? Give a try again. I'll give you 2-3 minutes more, then we'll solve it, like 6:18, maybe 6:17 or 18.
Ma'am, maybe 8.
Yes, the answer is 8. You're correct. What about others? Only one of you have solved? I think some other person was also. Saf has solved. Aman, you were also solving? You got the answer? Yes, Aman, you are correct. Maybe it's 8 only. Okay, let's start now. So now I want you guys to tell me, to guide me, so that we'll make the session as interactive one. How to start? First of all, what to see? First of all, in AIMD, we are in slow start phase. What does slow start phase first of all mean? Though we are multiplying by 2, why we are saying slow start phase then? Yes, yes, you have solved it. I want that this concept should be very clear to you. It's also an important concept. Miss Normer, we start at very low number. Yes, absolutely correct. So we are starting at very low number. It's not that we are starting at lower, like slower phase. The like phase, it's like multiple of 2. It's like going very fast. But we are starting from a very lower number, that is 2 MSs, or a very lower number, like 1 or 2 MSs only. So that is why it's called a slow start phase. Absolutely correct, Aman. So we are starting from slow, like 2 MSs. That is the starting transmission 1, I'll say. We are at slow start phase. I'll tell you who, everyone, transmission number 1. This is first transmission, that is 2 MSs we started. And then now new congestion window is, whenever we are starting the congestion window, we are at slow start phase. It is always the multiple of 2. So 2 multiplied by 2, that is 4 MSs. Now my new congestion window is basically 4 MSs. Now transmission number 2. Now the congestion window is 4 MSs. It was 4 MSs. And what is the threshold? 8 MSs. I have to be in the same phase, the slow start phase, until 8 MSs. That is what they have written. Let's again read the question. Consider an TCP AIMD algorithm where window size at the start of the slow start phase is 2 MSs. So that's why we started at 2 MSs. And in slow start phase, it is like multiple of 2. And the threshold at the start of the first transmission is basically, it's like, I think, it's 8 MSs. So threshold is basically 8 MSs, which means I have to be in the slow start phase until 8 MSs. And now if I check that 4 is less than 8, so it's fine. So I can again multiply by 2, that is 4 into 2, that is 8. So now the new congestion window size is 8 MSs. Transmission number 3. Yes, now can you tell me, those who have solved, Saf, Aman, and others also, what will happen now? Come on.
Ma'am, after this threshold will be heated and then we will got 8.
Yes. Absolutely correct, Saf, and absolutely correct, Aman. Now we have entered AIMD part, as slow start phase is over, as the threshold was 8 MSs, congestion avoidance, or AIMD. Now, what is the new congestion? Now, as 8 is 8, as you have told that the threshold has hit. Now, what will be the new congestion window size? Yes. Come on.
9 plus 1.
8 plus 1, 9. Correct? Transmission number 4. Now, as we have hit the transmission, now we have entered the additive increase. The name suggests that we have to increase it basically. That is now 8 plus 1. We are increasing by 1 MSS plus RTT. That is why it's like 8 plus 1. Now, transmission number 4. Again, it's like 9 plus 1. That is 10. Now, what happened in fifth one? The starting congestion window size was, we started with congestion window size 10, but as we have written the question something about fifth transmission, can you tell what happens? Timeout has occurred now.
And reset to 1.
Reset to 1.
Yes, ma'am.
Are you sure?
Yes, ma'am.
What about others? Yes, come on. Come on. Okay. Now, what would be the new threshold? Whenever I like there is a timeout, there are certain things. First of all, in slow start phase, the first rule is that it's multiplicative of 2. We did it nicely. When we reach to the threshold, we are additively increasing. We did it correctly. Now, when the timeout has occurred, there are two things, like the next thing I'll discuss in the further lecture, though I was thinking to discuss it afterwards only, but it's fine. We'll have the numerical this, and then again, same numerical, solving it with the 3 duplicate acknowledgement. That is some other way. Okay, now, when the timeout has occurred, our threshold change. Now, the earlier threshold value was given as 8 MSS in the question. Now, any idea what would be the new threshold value?
5, 10 by 2.
10 by 2, 5. Yes, I saw your chat now only. Okay. So it's basically 5, 10 by 2. So our threshold value is basically half of this congestion window size. That is our new threshold. And now, what is our window size? It's not 1. What is it? It's the starting one, which is 2 MSS. Again, we have gone to 2 MSS. Now, again, we have gone to the slow start phase. Now, transmission number 6. What will happen now? What is the new congestion window size? Come on. Come on, class.
Ma'am, again, we will restart slow start.
Yes,
1,
yes.
then 8 transmission will be 2, and again 4.
Yes, yes. But the starting is only 2. So we are starting from 2, not from 1. As in the question, the starting value is 2 only. So
Yeah.
2, then 4. Absolutely correct. That 2 and 2 multiplied by 2, that is 4. Now, what will happen in transmission 7th? Any idea?
Ma'am, maybe 8.
8. But what is the threshold?
5. So it will stop at 5.
So it will not be 8. What will happen now? It will be basically 5. TCP basically exits the slow start phase, enters the congestion avoidance phase, because it can't go to 8 MSS because the congestion window, like the threshold is basically 5 here. So that's why we are now in additive increase, multiplicative decrease. Then transmission number 8. Again same, 5 plus 1, 6. 6 plus 1, 7. And 7 plus 1, 8. So that is why final answer is 8 MSS. Any doubts? I'll again explain. I'll again explain from the starting. Any doubts?
No, ma'am.
What about others? Only two of you have understood. What about others? Those who are doing for the first time?
Well, it's actually some of these concepts are very new. It's not able to
Yes.
get it text. Sorry.
It's fine. It's fine. So let's understand it again. So what we are here doing is we are basically first of all having the slow start phase. The slow start phase is like we are normally like multiplying by 2 here in the slow start phase till the threshold will be achieved. That is there. Or okay,
Why two? Why two? Why is it two?
it's the rule that we are basically doing the exponential increase here, like we are increasing it exponentially. And before, because we haven't like we know that okay, the congestion is not there, so we'll increase by like it's they have taken that okay, let's increase it by multiple of 2 only, not very slow, because we know that we are far away from the congestion here. So it's okay, the receiver rate flow is not like they can handle it, there'll be no congestion, so let's move freely. So let's increase the rate very fast. That is their main motive. Let's increase the rate very fast until a threshold will increase. When the threshold is increased, then they think okay, now this is the threshold, we have to be somewhat slow. So that is why we increment it additively, like we are increasing it by 1 here, the MSS. Anyone else? Someone can explain this so that I can think that anyone have understood. Yes. One more thing, like what is multiplicative decrease here? What is additive increase here? Come on. This was just a numerical part. What is the main motive? As I have tried to explain also. What do you mean by AI in additive increase? What is MD, multiplicative decrease? Come on. Come on. Come on. Yes, class. Okay. So first of all, as we have discussed that, okay, when we are in the slow start phase, as we now know that there is no congestion, so basically we are going very fast here, okay, because there is no no congestion thing. So okay, let's go with the factor of 2 uh, like for that, and that is why we went by the factor of, like multiple of 2 here. So here, when I was in the slow start phase, I went to 2 MSs, then multiplied by 2, then I got 4 MSs, then multiplied by 2, then I got 8 MSs. Now now the threshold is achieved, like threshold is achieved. Now, which means that there is a congestion avoidance phase. Now I have to be a bit slow here. So that is why I went through additive increase thing. Additive increase means I have to increase by 1 MSS per round trip time. So I increased it by 8 plus 1, that is 9, then 9 plus 1, that is 10. And then there was in transmission number 5, as mentioned in the question, there was a packet loss or timeout basically. And when there was a timeout, I did multiplicative decrease, which means I reduced it to half the congestion window. To reduce the basically congestion, I reduced it to half. As the name suggests, additive increase, I increased it, multiplicative decrease, here I reduced it to half, and then again started the additive part. Any doubt?
Okay, so okay. So quick question. So additive increase means it's always plus one.
Actually, there is a reason why it's +1. Yes, there is always +1 only. But yes, we'll go in detail with that part also in the further lectures. Though it's +1 only, there is a formula from where it came +1. I'll go in the further lecture. That's why I was thinking to have the numerical afterwards. Then I thought, okay, let's come. But there'll be a same.
And then
Multiplicative decrease.
sorry.
That is basically when
Okay.
a timeout is there,
And
then
multiplicative degrees is also
divide by 2 only, half.
yeah. So it's multiplicative. So multiplicative degrees is always divided by 2.
Yes. Any doubts? Any confusion in understanding?
No, ma'am.
Now someone can summarize the concept of AIMD. I don't want that it should be like going above the head. As there was a nice question, why multiplying by 2? Why we are not linearly growing, and why we are I told you we are exponentially growing. Why we are doing so?
So multiplication by 2 is because we want to achieve that optimum rate very quickly, because we start at a very low number.
Yes. So basically, we have to discover the network bandwidth, or I'll say we'll quickly reach the network capacity without wasting the time, I can say. So we are basically to be fast. So we are basically going with multiplication of 2. And then what if I linearly grow? It will take very long. Wait a second. What if I linearly grow in this earlier case only, like 2 plus 1, 3 plus 1? If there is a linear growth, obviously, it will take a lot of time to reach network capacity. Am I correct?
Yes, ma'am.
So that is why basically we are we are growing exponentially here. Now, okay, one more. I'll now give you the numerical. I hope so. You have understood the concept and you can solve it easily. I hope so. A similar question only. Consider TCP connection that implements AIMD algorithm. Connection starts in slow start. With initial congestion window. One MSS. Slow start threshold. 16 MSS. Assume. Okay, leave this one. Wait a second. Assume that during congestion avoidance, loss is detected. When congestion window reaches 20 MSS. Given Let's take it as homework problem. Round trip time is equal to 100 because we have to cover many concepts further as we are already delaying. 1 KB. Determine. And please, you have to remind me if you are unable to solve any of the homework problem or so. Or maybe you can mail me. Average congestion window size over 1 congestion cycle. That is from just after loss until next loss. Average throughput over that cycle. I want that you should go with this question so that you can understand the concept of throughput as well and everything. Just take it as a homework problem. Take the screenshot or photo of it. I thought the question is like this only. Okay, it's different one. Should we proceed? Okay. If you will have any doubt, please mail me or we can solve in the next class. I have also not solved till now. I've just written the question. So, okay. Should we proceed?
Yes, ma'am.
Okay. I hope so. AIMD is cleared. Any doubts?
No, ma'am.
No, ma'am.
Now coming to, again, I'll ask same question I have asked multiple times. What is port number? What is IP address? I hope so now you know about this, the difference and what is it. I want to basically, there's a host 1 and host 2. I hope the host 1 wants to communicate with the host 2. And first of all, what is port number? What is IP address? Then we'll go further. Can you tell me?
Ma'am, I know about IP address and port, but today is my first class, so maybe I am wrong, but I will try. IP address is Internet Protocol address which is assigned by host to their client or node, and port number is like a channel between them. So multiple channels are between them for communicating.
Okay. What about others? Is he right? I think others are attending the class daily.
Port number is for like identification of a process on a
Yes.
particular host.
Yes. And IP address? Please mute yourself if you.
Yeah, IP address is for
Yes. Come on.
yeah, IP address is for identifying the host.
Yes. So identifying for the device that is or machine that is IP address, and to map to a particular application or a process that is basically port number. And that we have discussed multiple times. So now when we are basically there is a I'll say we have the communication between application in one machine to application in another machine. There is a logical pipe which is used here. For the between the sender and receiver, that is basically used. Which consists of source IP, source port number, destination IP, destination port, source sequence number, and destination sequence number. This logical pipe is identified by a tuple with of the 6 elements containing these IP addresses and port numbers basically. And we have some primitives. I'll listen state, connect state. I'll go in detail, don't worry. Send state, receive state, how the communication happens. Basically, this is those transport layer primitives. These are the states basically in which a particular server or a client is. Now, can you tell me what are these states and how the communication is happening between the server and the client? Anyone can explain me in detail? First of all, what is listen state?
Server is idle and waiting for any connection request.
So basically, this is by the server. So if I talk about the listen state, it's like server or machine. It it is basically ready to accept a connection. Can I say?
Yes, ma'am.
Yes, ma'am.
Or as you said that it is idle, or maybe it's not. It's idle and it's ready for the connection, and it's saying that okay, I am in the listen state. You can now say send me any connect. Now, what is connect? I was going to explain about connect only, so I want to ask you.
Client sends the connection request and server accepts it after all the acknowledgements, the three-way handshake.
Yes,
Basically,
absolutely correct. The
connected.
three-way.
Both are connected.
Connect. Okay. So basically, we are asking whether to establish a connection. That is basically a connection request is sent, and if they are connected, then only we can send the a message or receive the message. Am I correct by saying this? If we are sending or receiving the message before connecting, obviously that message will be invalid here. And
yes.
First connect, and then we have to basically, I can say that if connected, then send. Else, I have to wait for the connection. Same side receiver, if connected, then receive. Otherwise, wait for the connection. Before sending or receiving, system has to initiate a connection in simple words. And then we come up with a disconnect, that is basically releasing a connection. And now connection establishment, coming to that part. So these were the simple primitives only. The server is in the listen state, that okay, I am idle, or I am in the listen state, you can now send me. Now the connection has to be established. Once the connection, the three-way handshake or in TCP or so, and once the connection is established, then only I can say that the messages can be sent or received, and then we can disconnect the connection here. Simple thing. Now coming to connection establishment phase. So as we have done, we have one client, server, The server, as you told me, that it's in the listen state, then only the connect request can be sent by the client. So this connection request is sent, acknowledged, and then the connection is established. And now once the connection is established, data can be sent, and then receive. Similarly, disconnect request can be sent if I want to disconnect the connection. And acknowledge. Simple, same thing, same primitives are used. Clear?
Yes, ma'am.
Okay, maybe I have taken the screenshot of the diagram. Wait a second. Mm. One minute, I'll just check. Don't want to waste the time. I've taken. Okay. I think my screen is not visible. So I took the screenshot from the video lecture only, just to save the time. Now, can someone explain me this part? Fast, as we have to do socket programming also. Like you guys understood the socket programming as well in the class. TCP we have to start with though. TCP, UDP, and then socket programming. You understood, or you want me like just to give you the C file and then you can, or you want me to program it the way I'll plan the next lectures and so. Yes, class. If you want me to send you the C file of like server part, the client part, I can do so. If you want me that in the class we should discuss the programming part, then it's fine for me. Both ways are fine.
Discuss the programming.
I think, is it okay? What about others?
Yes, ma'am. Same. Discuss.
Yes. Okay, I'll discuss then. Okay, you can go over the code. Okay, yes. What I'll do, though I have written the code, done with the coding part, I'll go with the code. I'll write the comment part for everything, like what we are doing in each line, how we are doing it. I'll not write the code in the class, but I'll write the comments with each line and I'll share the code as well. And I'll explain you the overall concept as well. Okay. I shouldn't, okay, now coming to again this part. Now, can you tell me what is happening in this diagram as it's discussed? Come on, fast. Simple, the same thing is happening. There is a server part. This one is the server part, I'll say. This dotted part, and this is the client part. Now, can you tell me can someone explain this state diagram to me? Come on. Yes, class. I can expect this. It's just a connection.
Ma'am, first of all, both are in ideal state. Then active establishment pending and passive establish pending. After this, both are connected. Then the important file where sended anything, and then again disconnected.
Simple thing. First
Yes.
of all, sorry. This part is like client part. Dashed part is server part. And client initiated a connection. They both were in idle state. The client initiated in connection, active establishment pending. It is waiting for the connection establishment from the server side. The server here received connection request message. Now the connection is basically established. Connection accepted segment received. If it is received, wait a second. If it's basically received, earlier it was waiting. If it's received, then which means connection is established. Now, after the establishment state, they can send or receive the data. As we have discussed, once it is an established state, sending or receiving the data is possible. Now, the same way here also, that the disconnect request is basically sent, and once a request is received, then the again they are going to the idle state. Any doubt? Is it fine?
Yes, ma'am, it is clear.
So we have done the ARQ protocols and flow control and reliability, in which we have then we have also done congestion control services, which we have done. In flow control and reliability, we have used various ARQ protocols, stop and wait. Then we have gone with the go back and SR protocol. Some numericals also we have done. That sender will not send the data, basically, which is more than the receiver rate. And then we have also studied about the sequence numbers as well. Then the congestion control, that is basically AIMD thing, which we have done here. That, okay, we are basically going exponentially. Then we are basically increasing additively. And then we are dropping it multiplicatively. That is what we have done here also. And that's it. Now coming to the TCP thing, that was the transport layer. Now we have two protocols, TCP and UDP. We have discussed many times the difference between them. Just a quick difference. Yes, come on. Quickly.
Yeah, TCP is connection oriented and UDP is connectionless.
Yes. Or TCP is more reliable because it is connection oriented, as you told me, and UDP is less reliable, but is fast. On the other hand, that will go in detail how it is fast and all, as it is connectionless, basically. In other words, in simple words, I can say. So now coming to TCP, TCP helps in basically, if I talk about network layer, obviously this packet drop and all these things are not taken care by network layer. And when we are going with the different type of technologies, if I say that like we have wireless technology, one part of internet is using wireless technology, the other part is using wired, the other part is using optical fiber cable. So on top of that, we have to transfer the data. For that, the TCP help us for like over the unreliable, I'll say, inter-network case. So these all challenges, having the different different technologies over the different technologies, different bandwidth, different delays, the packet loss and all, these challenges are all handled by the TCP. And we have various standards also. You might have seen in the slide as well, there is something called RFC. That is just a standard documentation, I can say, in which you will find what is basically the values and parameters of everything, like go back and has like whole documentation is there. That is basically RFC 112. That is telling what is about like SR and what is that is all the documentation part. Now, if I talk about socket, as like we started with, that there is a logical pipe between them to connect basically host A and B. That is basically they use the socket, that is socket only. Now, if host B wants to send data to host A, I'll say host B. Suppose it uses the write system call to write in socket. And I can say that this will be basically transferred among different protocol stack, whatever, and then host A will read it. It will make a read system call to read the data from the socket. So when I have to transfer the data from the host B to host A, what I'm doing, I'm just writing on the socket, making a write system call, and from the other end, I'm making the read system call. That it's just an I'll say gist of it. Nothing I'm telling you about the sockets. That I'll explain now only, maybe. And any doubt what is basically this socket? Though I'll go in detail, don't worry about that. Any doubt?
No, ma'am.
Then there was something written, Unix model of socket implementation. Can you tell me what is Unix model? What is the main task of Unix model? Like Unix like model, what does it do? How does it works? The OS thing or model basically. Come on.
What model?
Unix model of socket implementation. What do you mean by Unix model? The OS. What? How does it?
OS provide some
Mm-hmm.
interfaces to for the implementation of the socket. So they things like say listen or send, receive, all these things. It provides interfaces for these things.
Yes, absolutely correct. So it is providing the interface, which is basically simple, or I'll say it is model. There is modularity. What do I mean by modularity? Here, why we are like complex task, they are broken into modules or simple task. I'll say it's simple because it's focusing on a specific task only, and there is a word written as internet daemon. Can you tell me what is that? Don't worry if you are unable to get what is socket or anything. We'll discuss. What is internet daemon? What is daemon first?
Ma'am, I think background process which are working behind the connection.
Yes, absolutely correct. Daemon is basically a background process. Now coming to INETD, like what they are doing is they are basically, I'll say, on demand service management, we call it. This start a specific service only when it is needed. That is basically a background process which is running, and and we'll discuss all these things in detail in the socket programming part. Don't worry about that. This was just a overview that socket is basically used to connect. We are writing from one end, we are reading from the other end, and Like there are various functions here, and it's basically Unix model of, I mean to say, we are having the simpler functions here in which the complex task is broken into the simple one, and background processes are running, and it's basically on demand service. Whenever it starts only when the specific service is needed, not otherwise. This is how it will work, though I'll come to that, don't worry about that. Now coming to TCP, is it byte stream or is it message stream? Any idea?
What is?
Is it byte stream TCP connection or message stream?
Message stream.
What about others?
UDP is a byte stream.
TCP is
Reverse. TCP
Reverse.
is byte.
TCP is byte stream.
Oh.
So basically, suppose we are sending these segments, and suppose this 2 and 3rd segment get lost. So now what will be notified to the host B? Whether will it be notified that 2 segments are lost, or how it will be notified? If suppose 1, 2, 3 segment is 2 and 3 are lost, 100 to 200, or first segment is received by a receiver. Now what is notified to host B? Or what is notified, how it will interpret that 2 segments are lost, or what is lost here? Any idea?
I think 2 segments are lost.
What about others?
Please repeat, ma'am.
I'm saying that, like, suppose these 3 segments are sent from host A to host B, and these 2 segments, this one and this one, it get lost. So now only this 100 to 200 bytes, that is basically correctly received. So what will be notified, like whether the 2 segments are lost, or how it will be notified? What has to be retransmitted?
So all the byte number 200 to 201 to 400 will have to be transferred. They
Yes,
can be in one message or multiple.
Yes, absolutely correct. As suppose here I'm writing it, here I'm reading it, host B is sending to host A. Now if 2 and 3 are lost, it's not like segments are lost. It's like 201 to 400 bytes are lost. It needs to be retransmitted. So now one more thing, if it needs to be retransmitted, it's not that in the same way, in the same earlier division it has to be retransmitted. I can retransmit it, like they can retransmit it by like this only. Division can change as well. Message boundaries, these divisions, they are not preserved. Is it clear? Yes, class?
Yes, ma'am.
So, like suppose I have to, as there was an example given there also, like 4512 bytes. They have to be like they are written, and then this 4512 bytes can be written, or 21024 bytes can be written, or 12048 bytes can be written. It can be written in any way, and the receiver can also read it in any way, because they don't know how the division is, how the chunks are basically divided. Like here also, when they were lost, the division was changed here as the message boundaries were not preserved. Is it fine? Should I proceed? Yes, come on.
Yes, ma'am.
Now about TCP segment. Can you tell me what is MTU? Yes, comment.
Maximum transmission unit.
Maximum transmission unit. Now, what does it mean? How much data is gone in one flow? Am I correct by saying in easy words? How much data is transmitted in one go? Yes.
But how is that different from MSS?
MSS is maximum segment size. Okay. Yes. Yes. Anyone? Can you tell me the difference?
Green.
What's the difference? What is fragmentation? Anyone? Maybe when I'll go with the network layer or so, I can explain. Or let's go. What I have written? Anyone? There's a basic difference only. Okay, leave this part. Maximum segment size means how much basically the data has to be transmitted. And if the maximum segment size is very large and it is exceeding MTU, maximum transmitting unit, it requires fragmentation. Though I've used many technical words, I think so. Any clarity with this part? Leave this. I'll come to this afterwards. Any clarity?
What do you mean by fragmentation?
Dividing into smaller parts. So basically, this is the maximum segment size. Maybe I have to explain more easily. If I say rather than this, first of all, MTU, if I say it's the max size. Exceeds MTU. Okay, wait a second. Of full packet. This is MTU, which contains data plus the headers thing. IP header or TCP UDP header. This is basically MTU. MSS, in easy words, okay, leave this also. I'll come to this fragmentation and all afterwards. MSS is basically only this data part, this payload part. In simple words. Now understood? I'll come to the fragmentation part afterwards.
So payload is nothing but the data, or
The header part. Payload is the data part. Am I correct? Or yes.
Payload is a header.
Yes,
Okay.
ma'am.
Without
Payload is the actual data carried.
actual data part. And without headers,
Sorry,
that
I
is
didn't. Sorry.
simple words. Yes.
Without header is payload.
This wait a second. This is data part plus the header part. This is MTU. The single data part, that is MSS. Only data part without headers. So I can say in simple words, MSS without, oh sorry, MTU without headers. It's basically MSS. Though there are certain things as well, I'll come to that afterwards. Am I correct? Any doubt?
So MTU includes headers.
Yes, ma'am.
Yes. In lecture, professor said, okay, you're writing. Larger IP addresses splitting into smaller MSS is a parameter that controls data packet. In lecture, professor said that MTU will be converted in. Yes, anyone? Yes, any doubts? Aman, can you unmute and explain if you want to say?
Actually, ma'am, I was not able to remember when MTO was discussed
Though it
specifically
will be
because
discussed for the lectures again.
it was said that it would be covered in
Yes.
DLL.
That's why I'm not going in detail. Just I'm saying that it's like without headers and it's with headers basically. MTU is with headers and MSS is without headers. Though I'll come to that fragmentation part and everything. Don't worry about these terms, okay? Let's take it like, okay, let's I'll say it will, the header part and all, just with header or without header, just take it for now this only. But I can't say without header is always equal to MSS, though there are certain things also, networking conditions and everything. A small, for now, just take it's without headers and it's with headers. Should we move forward?
Yes, ma'am.
It is approximately, but it's not equal. Okay, leave that part. I'll come to it afterwards. Now, one more thing. What is challenges? What is the challenge faced in TCP design? Anyone, can you tell me what can be the challenges?
Out of all
Ma'am,
the
very
packets.
slow TCP, but UDP is fast.
One of the challenge. And what about design? Something about packet
Out
that
of order packets.
out of order packets. Okay. Okay. So handling out of order packets, it's difficult. So suppose that like 100 to 120 and 150 to 500. This is basically received and this is basically received. Now again, what sender sends it, and 120 to 150 was not received, and the sender, as again it will send, suppose it may send 121 to 160. So sorry. So now receiver will basically chop off this 150 to 160 because it doesn't need that. So basically the thing is, out of how order handling, I have received this packet, I have received this packet, this segment, and this is not received. So out of order is basically there. That is why the design is all somewhat tough here. Now again, going to TCP connection establishment, is it the same like we have done before as well? In detail, like I think 2 times I have explained this sequence number part. forbidden region part. Maybe I'll open that part only. It's the same thing. I think professor has explained it again. Last week. Okay, maybe you'll not understand. So anyone can tell me about like what was that initial sequence number? First of all, initial sequence number shouldn't be in forbidden region. Can someone tell me what was that thing? Come on. We have done previous lecture. That sequence number shouldn't be like if one connection is basically crashed, then the another connection has started, or because of timeout or so, then the same sequence number shouldn't be reused. Am I correct by saying this?
Yes, ma'am.
Yes. The idea is to prevent reuse of the same sequence number. Absolutely correct, Aman. So how can you tell me yes, this is the main idea. We shouldn't use the same sequence number which was in the last previous connection. If the previous connection is like basically two connections shouldn't have the same sequence number, duplicate sequence number sent. We as you have written, Aman, you cannot reuse the same sequence number. We can reuse. Can you think of the case we have discussed also? We can reuse the same sequence number, but there is some condition.
If we wait for a long time for the old ones to die, old
Yes.
packets.
So
Yes.
basically, if we wait for some time, okay, let's wait for some time. Now the old sequence shouldn't, now the data will not be transmitted from the older connection. The data will be transmitted from the newer connection only. So it's fine. What was the other thing? Either we can reuse the same sequence number after waiting for some time, or the other part is that the same sequence number shouldn't be the same, like there shouldn't be overlap between the sequence number. The other technique, what is the other technique? One is the time thing, we should wait. What is the other technique?
Ma'am, to use a different sequence number which is higher than the above.
Yes, absolutely correct, Nilanjan. So to use the higher sequence number, so which are not used before. So in the connection one, which old connection which were not used, so to use them. And as we have done that, okay, to wait for some time, and then like there can be, like if we are waiting for some time, there can be some attacks also, like flood attack, DOS attack. Can you tell me about flood attack or DOS attack?
Yes, ma'am. Denial of server. We create some bot which act like a client and send multiple at the same time.
So basically, multiple flooding of those packets shouldn't be there. If that is there, that is basically attack is happen, and that is why cryptographic functions are used. So I'm not going to go in detail with the cryptographic functions. So that are being used. Basically, security thing is used so that like to prevent from the attacks. Basically, connection establishment. You know the three-way handshake. Again, I'm telling you, one is like here, the synchronization message is sent. Can you tell me what I have written? The three-way handshake. Can someone explain me? Yes.
This is the three-way handshake for bidirectional communication between host A and host B.
What do you mean by bidirectional communication? Can you tell the class?
So it means that host A can send data to B and vice versa.
Yes, so basically two messages are sent by both host A and host B, as here SYN plus acknowledgement is there. That is why here the synchronization message is there, then the acknowledgement of this message is there, and again a new message is sent from host B to host A, and then the acknowledgement of the above message, and the new sequence number is there. So this is, we have done multiple times, and now talking about the connection release. The same way finish message or fin message here is sent. Can we explain this? And the other question is why there is a timeout in host A. What does it mean? Come on. So basically there is a finish message which is sent by host A to host B. Then if B wants to close the connection, message is sent finish plus acknowledgement. If it doesn't want to, then it will send the acknowledgement message only that I have received, not the fin message along with it. And whenever it wants to close, it will send fin. Here it is sending fin plus acknowledgement that okay, I want to close. Any doubt in this? The same way we have done the three-way handshake thing. Connection release synchronous. Absolutely correct, Aman. I'm not going to explain that state transition diagrams. They're simple only. The way, like they're just having how the connection listen states is the same thing, the connection establishment, and again the connection release. Fin plus acknowledgement is received, which means that the it's basically closed, and only acknowledgement is received, which means that the server is saying not to close. There can be simultaneously fin, both can receive fin also. So these things are basically discussed here. I think so that is clear only. Let's proceed. Go through this in detail, these parts. So whenever we are sending a segment, basically, if I say that 1 byte of data is sent, and I'm creating 21 byte of segment here because 20 byte of header is there. Does it make sense? What is the flaw which you can see, like with the 1 byte of data, 20 byte of header? What is the flaw which you can see here?
Ma'am, the header is too big for the data, and the header will automatically be detached when they will be going through the layers. So it will create some kind of transmission delay because of the large size of the header.
Yes, so delay is there, resources are wasted, bandwidth is
Yes,
wasted.
ma'am. Yes, ma'am.
There's so much of overhead. With the small amount of data, we are sending so much of header, so big amount of header, so much of overhead, huge wastage of bandwidth, huge wastage of resources. So that is why we come up with the delayed acknowledgement. What do you mean by delayed acknowledgement? Any idea with the name?
The acknowledgement will be delayed.
The acknowledgement will be delayed. Can you explain further? What do you mean by acknowledgement will be delayed?
The receiver will wait till it has got sufficient amount of data so that it can send an acknowledgement.
Yes. So basically, now I'm sending 1 byte of data so that more data can be received. It shouldn't be like for 1 byte of data and 20 bytes of header. I'm sending acknowledgement. Then again, 1 byte of data is sent or so. So to overcome with this problem, we came up with delayed acknowledgement up to suppose 500 millisecond. The receiver is waiting for the data, so in hope for that more data can be transmitted rather than 1 byte only, so that this overhead will be obviously again and again sending acknowledgement for this small amount of data. It doesn't make the sense. So they are delaying the acknowledgement part so that receiver can receive more amount of data from the sender part. Does it make sense? Now, can you tell me about Nagle's algorithm? One is delayed acknowledgement part. That how what we are doing in delayed acknowledgement, we are not sending the acknowledgement here. We are thinking, okay, let the sender send more amount of data because it's only 1 byte or small chunk of data. Let the sender send more amount of data, then only I'll send more acknowledgement. Now, can you anyone can tell me about Nagle's algorithm?
Ma'am, this algorithm used to reduce the number of small packets sent over TCP.
So what it is doing is, let's understand an easy word. So sender sends first packet immediately. Holding subsequent small packets until previous packet is acknowledged. I'm writing, go through it. I've written in easy words, or I can say enough data accumulates. Can someone read and explain me now? Nagle's algorithm, I've written in easy words. Come on.
So the idea of Nagle is to ensure that at any time there is only one small packet in the channel.
Is it so?
Because we wait for the packet sent by the sender to be sufficiently large enough.
I don't, wait a second. I'm not getting whether you are correct. I think so. Like, suppose I have A, B, C, D packets. Sender sends one small packet first to receiver. Why it's not waiting for more packets and it's sending one small packet. It's not waiting that, okay, the other packets will be accumulated, then only I can send. It's saying, okay, at the time I'll send the first small packet, that time until I'll reach until the acknowledgement is received, more smaller packets will be accumulated, then I can send the smaller packets. So I shouldn't hold for the first packet. Whatever I'm having, I should send it, holding for the subsequent small packets, so that previous packet, until that time the previous packet is acknowledged or enough data is accumulated, I can hold for it and then send. You got the point? Am I correct by saying this? Yes. So what we are saying that maybe in chat I'll say yes. Okay. So we are sending only one packet first, whatever we are having, not waiting for others. And now there is a thing written that whatever we have done, delayed acknowledgement and Nagle's algorithm. I'll explain it again. Don't worry. Don't go with each other. We, like, why they don't go with each other? They don't go together. You understood? I hope so. You understood about delayed acknowledgement and Nagel's algorithm. Now think about both of them and then think why they are not going together. Any idea? Yes, come on.
Starvation could happen, ma'am.
How starvation will happen? Yes, I know that starvation will happen. How that starvation will happen? Can you explain both Nagel and delayed how, and then explain how starvation will happen?
So what would happen if, say, Nagle has sent a small packet as it sends at the beginning, and it is waiting for acknowledgement, and meanwhile it is building the next packet to be sent. While at the receiver is waiting for some more packets to be sent so that it can send a big acknowledgement.
Yes, absolutely correct. Absolutely on point, I'll say. So, what is happening? Starvation is happening. As he has explained very well, that why the why the starvation is happening, why there is a possibility of starvation. That sender, it will send only small packet here in Nagel's algorithm. What does Nagel algorithm say? I'll send a small packet, and then whenever the acknowledgement will receive, I'll till that time more packets will be accumulated, then I'll sending. Now receiver, what receiver is according to delayed acknowledgement? Delayed acknowledgement, the receiver is thinking, okay, I'll wait for more packets, then we'll send acknowledgement. And sender, this is according to delayed acknowledgement. And Nagel's algorithm is thinking that, okay, when acknowledgement will receive, in that time, I will accumulate more packets. So here, sender will keep on waiting for the acknowledgement, and the receiver will keep on waiting for more packets. So this way, they are not going together, and they may go to starvation. Any doubts? What about others? Everyone have understood? If you haven't understood, I'll go again. I'll understand. I'll make it clear again. Yes, come on.
Yes, ma'am.
Yes, ma'am. Starvation concept, could you just explain that?
Okay. I'll explain again. So we have one delayed acknowledgement and one is Nagel's algorithm. Now what I'm saying is they don't go together. We can't run both the concepts together. Why we can't run both the concepts together? Let us see. Delayed acknowledgement says that receiver, the receiver will wait for the more accumulation of more packets, accumulate more packets, and delay. As the name suggests, I'll delay the acknowledgement. I'll not send the acknowledgement once enough packets are not accumulated, once enough data is not accumulated. Once enough data is accumulated, then only I will send the data acknowledgement back. So receiver said, okay, I will not send the acknowledgement because enough data is not accumulated. Nagle's algorithm says, I will send only small packet first, and once I'll receive the acknowledgement, then the enough packets will be accumulated, then I'll send the larger number of packets. But as we know that receiver is waiting for more number of packets, so it's not sending the acknowledgement. And according to Nagle's algorithm, the sender is waiting for the acknowledgement so that it can send the more packets, so it is not sending more packet. So here the sender is also not sending the data, and here the receiver is also not sending the acknowledgement. So both ways they are like nothing is happening here. The receiver is waiting for the packets, whereas sender is waiting for the acknowledgement part. So that is why starvation is happening. Clear
Yes,
now?
ma'am. Thank you, ma'am. This helps. Yes, ma'am. Thank you.
Yes. Let's move forward now. Coming to silly window syndrome. Any idea about that? Yes, come on.
Ma'am, due to sending of small data packets, the window size actually shrinks down, understanding that only small packets will be transmitted to the
Mhm.
receiver end.
Okay, let's see. So basically, suppose the sender has 10 Mbps, whereas receiver can receive only 1 byte per second. Now, obviously, so we have to send multiple small packets, and we don't want to send multiple small packets because of the overhead, because of the bandwidth. Significant bandwidth will be wasted and everything. So that is why again the same thing is happening. Small packets we don't want to send, so that is why we came up with the Clark solution. Anyone, can you tell me what is Clark solution? Come on.
Don't know, ma'am.
What about others?
I think the idea is that sender waits for so the receiver to tell that it has big buffer, big window size.
What you're saying, sender is waiting
So
for
that till the receiver advertises that it has got enough space, sufficient space, so the sender can send some big data packet.
yes. So basically, the sender is basically waiting so that until the sufficient space is available by the receiver. Can I say that? In simple words, the receiver, whenever receiver will have the enough buffer space, then only the sender will basically send it. So that is basically Clark's solution. And if I say that Nagle's algo and Clark's solution go hand by hand, they are complementary. Can you tell me how? As we saw that delayed acknowledgement are not they can't go hand by hand. Here they are complementary, go hand by they are complementing each other. Can you say how? Come on. Is it Clark solution is the receiver side thing, or Nagle's algorithm is the receiver side thing?
Ma'am, Clark solution.
Clark solution, and Nagle's algorithm is sender side thing.
Yes, ma'am.
What is Clark's algorithm doing?
In Clark, we wait at the sender, we wait till the sender has got some big basically the receiver has sent an acknowledgement that it has sufficient space in its buffer.
And
So
what about?
and
Yes.
in the Nagle also we wait till the sender has sent the acknowledgement. So in a way, sender can now send big chunk of data, and receiver can
receiver
advertise that it has, you can again send a big chunk of data. So it makes sense then.
Absolutely correct. Now, suppose that, okay, now as we have done about Nagel's algorithm and Clark's algorithm, one is for the sending application, one is for the receiving application, and both are going hand by hand, as he has explained. Now, if I want to send immediately rather than waiting, then we have some emergency like flags, like push flags. Suppose I don't want to wait for a huge amount of packet. I just want to send it because it's an emergency packet. It's an important packet. So the push flag, these flags also we'll study in detail that are basically used. And now retransmission timeout, TCP retransmission timeout, RTT, round trip time. Can someone explain me what is this? What is time retransmission timeout? Why we use it? There is a timer if the acknowledgement is not received. Within that timer, the segment is basically retransmitted. That timer is basically retransmission timeout. And if acknowledgement is received, I'll stop the timer. Basically, and like before the timer expires, the segment is received, as then this timer is basically stopped. That is basically basic concept. Retransmission timer means I haven't received the acknowledgement till this time period. I have to like retransmit the segment again. That is the thing. Now there was a question like how to calculate the retransmission timer, and why it's difficult in like if I talk about DLL and if I talk about transport layer. In DLL, as I have hop by hop in DLL, so how much time it will take from one to send packet to another, like the round trip time basically from sending and receiving, the dynamicity is very less, variation is less, so I can basically predict about the round like retransmission time basically easily. Now if I talk about transport layer, I have the internet. It's basically end-to-end connection from sender to receiver, not from like hop to hop connection. So dynamicity is very large in round trip time. What is round trip time? First of all, I'm speaking so many times. What is round trip time? And what I have spoken, like what is dynamicity, DLL, transport layer? Are you understanding?
Yes, ma'am.
Can you tell me?
Ma'am, round trip time is when the sender is sending a data and getting an acknowledgement back. The total time is the round trip time because it is kind of creating a loop for the sender. And in the DLL, we have the switches, L2 switches, which we can calculate the transmission rate by hop. So we have that kind of power. But in case of transport layer, we are using a logical bridge between the two layers in the internet, so it is difficult to predict the round trip time for that.
Basically, there are a certain dynamicity. There is so much of variations in transport layer because it's like from end host to end destination. Here it's like not from end host to end destination. In DLL it's like hop to hop only, so dynamicity is very less. So that's why round trip time is easy. So that is why retransmission time, it's easy to calculate because the variance is lesser here and variance is very high in transport layer, so it's very difficult to calculate.
Yes, ma'am. Ma'am, but I have one question.
Hmm.
As we know that the transport layer communication is lack of a logical bridge. The actual communication goes through the, I mean, the lower levels of the switches. So can we calculate the RTO from the actual RTOs in the DLL and sum it up in some kind of formulation and try to predict it for the transport layer, like from the bottom up approach?
You are
Then it,
saying okay, we'll come to know about DLL for each of the hop and then we can predict it for the transport layer easily. Is it what you are saying?
yes, ma'am.
Yes, we can do so, but still there can be various mistakes. There can be variations also because it's not there. There are different factors which are involved that we'll also discuss when we'll discuss about DLL. The error can be there, modulation techniques, multiplexing, everything. There can be many errors there when we are calculating it. So that is why taking from lower to higher, it will take it we can't be like sure with that. There can be variations again, there can be dynamicity again, I'll say. So that is why an approach is given to that, that is Jacobson algorithm. I know you're saying that okay, let us calculate from this DLL, this also DLL, and then whole we'll calculate for the transport layer. Still there can be certain variations involved when we are going from end host to the end destination. That is what I'm trying to say.
Okay, yes, I got it, ma'am.
Hmm. What about others? Understood? Before going to Jacobson or anything else, I think we can now, as 10 minutes are only left, we can go with the MCQ part.
Yes, ma'am.
The next was I think we have covered only slow start. That's what I'm looking at. What is the left? Then main part is UDP and socket for that week. Okay. Wait a second.
Ma'am, next week we are going to revise about the UDP and the socket part, right?
Yes, yes. UDP socket part. We'll try to complete those things.
Okay, ma'am.
Okay, I'll come to that part later. This is we have done now only. That's why I'm coming to this. What is the purpose of delayed acknowledgement in TCP? To reduce the number of acknowledgements sent, improving efficiency, to delay packet transmission for congestion control, to wait for sender's retransmission before acknowledging, or to improve the reliability of UDP. Yes, what about others? Only one of you is answering, and we have, I think, 23 participants. Yes, come on. What is delayed acknowledgement? Can someone unmute and tell me what is delayed acknowledgement?
Ma'am, I think answer is A.
Yes, the answer is A. Saf, you don't have to speak as this is the rule. We are going in. We have to write. You have to write in the chat with question number as well as the MCQ A, B, C.
Yes.
Whatever is correct,
Yes,
so that
ma'am, yes.
other can also do. Yes, the answer is actually A, to reduce the number of acknowledgements sent. Question number 2. How do Nagle's algorithm? Okay, Saf, can you tell me why the answer is A first of all before going to jump into the next question?
Ma'am, delayed acknowledgement features is to reduce the number of acknowledgement.
Basically, yes, I'm delaying the acknowledgement so that I shouldn't, if I'm getting the one byte, I shouldn't send the acknowledgement for that, and then the another byte I shouldn't send the acknowledgement again. So basically, if I'll wait for more number of data, only one acknowledgement of more number of data will be sent rather than acknowledging for the each packet. So basically, to reduce the number of acknowledgements sent, improving efficiency. Now, second, how does Nagle's algorithm improve TCP performance? Panashi, please write the question number as well with the option. Yes, come on. Absolutely correct, everyone. It's 2B. By combining small packets into larger one before sending. Which problem does Clark's algorithm address? Simple only. Everyone is correct here. Yes, others can also participate. I want everyone should participate here. Yes, it's 3A. What is the primary cause of silly window syndrome? This also we have discussed now only. Yes, come on. Come on. Only one of you have answered. It's easy only. What is the primary cause of silly window syndrome? No, Aman, it's 4B. Sending small segments unnecessary. Now only we have done that. Suppose the receiver is having 10 Mbps, where sender is having 10 Mbps, receiver is having 1 BPS. So we have to send it very large number of small packets to reduce that. That is why we came up with the Clark solution, the silly window syndrome. So it's 4B. Which TCP timer is used to detect lost packets? Yes. Absolutely correct. 5B, retransmission timer. TCP's retransmission timer is calculated using which method? Though we have to do it. We haven't discussed it. Okay, we haven't discussed this. Yes, Aman, you are correct here. It's EWMA, exponentially weighted moving average. Okay, I think we haven't done this. Kahn's algorithm. Okay, leave this. TCP uses which congestion control technique? Additive increase, multiplicative decrease. I thought the questions are okay. Okay, we haven't done it. I thought that we have. Okay, maybe the MCQs are. Now these are simple MCQs, I'll say. Again, that we'll solve in the next class, the MCQs which are left. Again, these are the simple only basics of transport layer. First question, which of the following protocol operates at transport layer? Very easy, MCQs. Why you are writing C, B, D actually, both TCP and UDP? Which transport layer protocol provides connection-oriented service? Someone answered also. Yes, Joseph, we only answered today about this. No, Saf. Incorrect here. It's basically TCP. TCP is connection oriented as well as UDP is connectionless. Though we'll discuss in next class. Connection. Though we have discussed about TCP, we are making a connection. Connection oriented means we are establishing a connection. Three-way handshake, which means connection oriented, establishing the connection. Which protocol is best for real-time applications? Absolutely correct. Can someone tell me why UDP is preferred for real-time applications and not TCP?
Because UDP has a better speed and some disadvantage of lost data pack, but efficient, fast.
Yes, absolutely correct. Both of you, Aman and Saf. So basically, UDP is
Because
fast.
of not ordering, so that's why it is fast.
No, obviously, the ordering is also not there, and connection less is it's connection less, and so many like overheads are not there. We'll
Yes, ma'am.
discuss which overheads are missing there. These services are not provided, so overheads are not there. So that is why. And we need for the real-time application, our main priority is that the application should be very fast rather than reliable. Like more priority is about being fast. So that's why. The transport layer ensures which of the following? Joseph, you can change your answer as well. Check properly.
What is meant by recovery here? Does it mean lost packets or something else?
Lost retransmission, we can say.
Oh, in that case, 4D.
Yes. Absolutely correct. It's 4D. What is the default port number of HTTP? This I think we have done before also. Five A, absolutely correct. Which protocol uses a three-way handshake to establish a connection? Let's be somewhat fast. Yes, come on. Absolutely correct. In 6C, in UDP, error checking is done using checksum, though we have to do it. Which field in TCP header is used for the flow control? Which field in TCP header is used for flow control? Window size, basically flow control, we have to see the window size. What is the maximum number of TCP connections a server can handle simultaneously? Ninth. It's basically D. It depends on system resources. How much actual number of connections are there? Which of the following is not a characteristic of TCP? Now only someone mentioned. Absolutely correct. Unordered delivery. MCQs, and we'll try to complete the socket thing, programming and everything. We'll do in the next class. And I'll again write the mail ID. And this is the channel name. I'll upload the video tomorrow. Thank you, class.
Thank you, ma'am.
Thank you.
Thanks, ma'am.